Beneath the tranquil veil of the night sky lies a universe brimming with horrors beyond human comprehension. In the vast spectral void of the cosmos, there dwell entities of such bizarre and daunting nature, they appear as though conjured from the darkest corners of a cosmic horror tale. Envision forces of unfathomable power, capable of extinguishing planets and distorting the very fabric of time. Within the cosmos's deepest shadows, where even light hesitates to venture, rest secrets that send shivers down the spine of the universe itself. Within the infinite expanse of the cosmos, when a star significantly larger than our sun exhausts its nuclear fuel, it marks the beginning of one of the most extraordinary phenomena in space. Imagine a star that is significantly bigger than our sun, possibly more than 20 times as massive. These celestial giants consume their nuclear fuel at an astounding rate. In the universe, a supernova explosion that outshines entire galaxies signals their downfall. Following this star explosion, the residual core must eventually confront its demise. It starts an incredible collapse under the force of its own gravity if it is huge enough, usually more than 3 times the mass of the sun. This collapse is so intense that the core's matter crushes into an infinitely dense point, known as a singularity. Around this singularity forms the event horizon, a peculiar boundary conceptualized by astrophysicists like Kip Thorne in Black Holes and Time Warps. This is the point of no return, where the gravitational pull becomes so overpowering that nothing, not even light, can escape, thus giving rise to a black hole. These stellar black holes are just one category in the black hole family. The universe also harbors supermassive black holes lurking at the centers of galaxies, including our own Milky Way. These are staggering in size, ranging from millions to billions of times the mass of our sun. Their formation is a subject of ongoing research, with theories suggesting they might originate from the collapse of enormous gas clouds or from the mergers of numerous smaller black holes over cosmic timescales. Supermassive black holes play a crucial role in shaping their host galaxies, influencing everything from star formation to the evolution of the galaxy itself. Venturing beyond the colossal supermassive black holes, we encounter the intriguing intermediate black holes. These cosmic entities, with masses akin to a cluster of stars, between a few hundred to several thousand solar masses, may arise from the merger of smaller black holes or as remnants of gigantic stars, offering crucial insights into the growth patterns of black holes. Moreover, the mysterious primordial black holes, which are thought to have formed soon after the Big Bang, may be present in the cosmic landscape. These might be as big as a mountain or as tiny as an atom, and they might provide light on long-standing mysteries concerning the origins of the universe and the nature of dark matter. In the realm of theoretical physics, micro-black holes present a fascinating possibility. These minuscule entities, possibly just a fraction of a millimeter across, yet with masses comparable to large asteroids, are hypothesized to form in high-energy environments where quantum and gravitational forces intersect. The search for these tiny black holes challenges our understanding of the quantum realm and could revolutionize our grasp of the fundamental principles of space and time. Investigating a black hole's anatomy reveals a world where basic physics is stretched to its utmost. Traveling into a black hole transports us to a place of cosmic terror and incomprehensible wonders. The event horizon acts as the eerie threshold of this abyss, a sphere of ultimate darkness where the gravitational pull becomes so immense that not even light can flee its grasp. This boundary, unique for each black hole and defined by its Schwarzschild radius, marks a transition into a realm where conventional physics loses its footing. Beyond this threshold of no return, the environment becomes increasingly hostile and bizarre. Space and time, those fundamental fabrics of the universe, undergo severe distortions. Imagine time stretching and slowing down, a phenomenon known as time dilation, and space being twisted and warped under the extreme influence of gravity. Time dilation is a phenomenon from Einstein's theory of relativity, where time passes at different rates for observers in different gravitational fields or moving at different speeds. Near a massive object like a black hole, or at high speeds close to the speed of light, time slows down compared to an observer in weaker gravity or at rest. Moving further into the depths of the black hole, the journey is rife with theoretical terrors. Paths once straightforward now inexorably curve inward, compelled towards the singularity. At the singularity, an area of nightmarish proportions, matter is believed to collapse into an infinitely dense and infinitesimally small point. Here, in this heart of darkness, the very concepts of space and volume lose meaning. Traditional physics, including the towering theories of Einstein, falter in explaining what happens within this singular point, making it one of the most enigmatic and terrifying concepts in astrophysics. Circling the event horizon is the accretion disk, a maelstrom of destruction. Here, gas, dust, and fragments of devoured stars heat to unimaginable temperatures, spiraling violently into the black hole. This swirling vortex emits high-energy radiation, a ghostly and powerful glow that serves as a testament to the black hole's insatiable appetite. It's a chaotic, hellish environment where matter is shredded and energy is unleashed in a cosmic spectacle of destruction. In the case of rotating black holes, the surrounding ergosphere adds another layer of dread. In this bizarre region, space-time itself is dragged in the direction of the black hole's rotation. The boundary of the ergosphere is not a fixed shell, but a dynamic, fluid-like surface, distorting reality in a way that challenges the very nature of physics as we know it. In the middle of these scary characteristics, the idea of Hawking radiation adds a subtle twist. Proposed by physicist Stephen Hawking, this theory suggests that black holes can emit radiation due to quantum effects near the event horizon, hinting at their slow but eventual evaporation over eons. This radiation, while faint, stands as a beacon of quantum mechanics in the overwhelming darkness of black hole physics. Although black holes' all-consuming nature suggests a cosmic threat, their impact goes much beyond simple annihilation. Black holes can act as cosmic catalysts. When a black hole pulls in matter, it doesn't always devour everything. Some of the material gets accelerated and ejected back into space at nearly the speed of light. The intense radiation from the accretion process can also affect the interstellar medium, the gas and dust filling the space between stars. This can lead to either the suppression or triggering of star formation in neighboring regions, playing a subtle yet profound role in the life cycle of galaxies. In the bustling centers of galaxies, black holes can induce dynamical friction, a process where the gravity of the black hole interacts with nearby stars and gas. This friction can cause stars to migrate to different orbits, or even be ejected from the galaxy at high speeds, altering the very architecture of their galactic homes. Another fascinating aspect is the role of black holes as cosmic recyclers. By breaking down matter to its fundamental constituents, they contribute to the cosmic cycle of matter, dispersing elements that can later be part of new planets and stars. Furthermore, black holes can change how electromagnetic waves propagate, which can have an impact on how light and radio waves are transmitted throughout space. This may result in events such as gravitational lensing, a phenomenon that gives us a distorted or magnified vision of far-off objects by bending light from nearby stars or galaxies around a black hole. Some scientists propose a mind-bending theory, suggesting that our entire universe could exist within the event horizon of a massive black hole. Known as the black hole universe hypothesis, it speculates that the singularity at the center of a black hole might connect to another universe, giving rise to the possibility that our reality is just one chapter in a cosmic multiverse. It serves as a chilling reminder of how the black hole may bend space, time, and our understanding of the cosmos, inspiring wonder and anxiety in humans in the face of these cosmic mysteries. When we think of planets, we often picture the familiar, orderly orbits of our solar system, from Mercury's swift path to Neptune's distant loop. A group of intergalactic vagrants, planets without a star to call home, exist outside of the peaceful orbits that make up our solar system. These are the rogue planets, lone wanderers lost in the great emptiness of the galaxy, isolated and exposed in the enormous fabric of space. Unlike the familiar planets of our solar system, rogue planets do not orbit a star. Instead, they drift freely through the galaxy, unbound by gravitational ties to a solar system. These interstellar drifters range in size and composition, from gas giants larger than Jupiter to rocky worlds akin to Earth. They roam the vastness of space in solitude. Devoid of a star's warmth, these planets are realms of intense cold, where the lack of sunlight transforms their surfaces into frozen wastelands. Imagine landscapes dominated by ice, possibly with towering structures akin to mountains and valleys, all sculpted by the relentless chill of space. These planets, cloaked in darkness, could feature surfaces where even atmospheric gases become solid, creating surreal, icy formations. The absence of light renders them invisible to the naked eye, painting a picture of ghostly worlds wandering unseen through the galaxy. Their true appearance, hidden in the shadows of space, leaves much to our imagination, hinting at a variety of unearthly terrains and frozen vistas, far removed from the warm, lit conditions of planets like Earth. Rogue planets lead a nomadic existence. Some were formed in the early chaos of their home systems and flung into space, while others may have formed independently in the galactic void. What makes these celestial nomads so frightening? It's their stealth and unpredictability. Shrouded in darkness, they travel unseen, their paths unknown. For years, rogue planets were mere theoretical entities, speculated by astronomers, but not yet seen. These hidden worlds were thought to exist in the cold expanse of space, far from any star's light. The breakthrough came with the first observational evidence. Using techniques like gravitational microlensing, astronomers began to spot these elusive planets. One of the first identified rogue planets was PSOJ 318. 522 discovered in 2013. It's a young, Jupiter-like world floating alone in the vastness of space. Rogue planets, hidden in the cosmic shadows, present a unique challenge to astronomers. How do we detect these elusive wanderers that shine with no light of their own? Unlike stars or planets orbiting a star, rogue planets don't emit significant light, making them virtually invisible against the vast backdrop of space. One key method we use is gravitational microlensing. This phenomenon occurs when a rogue planet passes in front of a distant star, bending and magnifying the star's light. Microlensing is a powerful tool. It allows us to infer the presence of a planet from the way its gravity distorts light, acting as a cosmic magnifying glass. A question comes to mind when we gaze out into the expanse of the cosmos. How many rogue planets are there in our galaxy that we are unaware of? Since rogue planets do not emit light of their own, counting them becomes a formidable challenge. This lack of luminosity renders these celestial wanderers nearly invisible, complicating our efforts to estimate their numbers in the vastness of space. Yet, what we've learned so far is astounding. Some astronomers suggest there might be billions, perhaps even more rogue planets than stars in our Milky Way. Research, including studies using gravitational microlensing, points to a surprising abundance of these interstellar objects. They could be lurking in every corner of our galaxy. If true, this means that rogue planets are a significant, though hidden, component of our cosmic environment. They play a far greater role in our galaxy's makeup than previously imagined. One of the most terrifying risks they pose is a direct collision with Earth. Though the odds are astronomically low, the impact of such an event would be catastrophic, potentially ending all life. We've witnessed the destructive power of smaller celestial bodies, like the asteroid that contributed to the extinction of the dinosaurs. The immense gravity of a rogue planet passing by could disrupt Earth's orbit, triggering catastrophic climate changes or pulling us out of the habitable zone. The disturbance isn't limited to Earth. A rogue planet's path through our solar system could wreak havoc, destabilizing orbits and potentially flinging other planets or moons out of their paths. Current technology makes spotting these interstellar intruders a challenge. We rely on indirect methods, which may not give us enough warning to react or prepare for a potential encounter. In the cosmic narrative, the aftermath of a supernova is often associated with the birth of black holes, but that's not always the case. As remnants of supernova, they present a different path in the cycle of stellar evolution, one that challenges our understanding of matter and gravity. Contrary to the common path leading to black holes, not all supernova result in these dense, light-swallowing giants. Stars with a mass lower than the threshold required to form a black hole take a different route. As they explode in a supernova, their cores collapse to a point of extreme density, but instead of becoming a singularity, they form neutron stars. This remarkable transformation results in some of the densest matter in the universe. Imagine a sphere just 12 miles wide, no larger than a city, yet harboring more mass than the sun. This is the domain where a single teaspoon of matter weighs a staggering 1 billion tons. Picture the Great Pyramid of Giza, not sprawling across the desert, but compressed into a grain of sand, or all the cars on Earth condensed into a thimble. Such is the unfathomable density of these remnants of supernova explosions. But their strangeness doesn't end there. Their gravity is 1,000,000 times that of Earth's, so intense it warps space, bending light around them. These stars are not just dense, they are also incredibly fast spinners, some rotating hundreds of times per second, emitting beams of radiation from their magnetic poles like cosmic lighthouses. These beams, coupled with their rapid rotation and extreme magnetic fields, unleash torrents of electromagnetic radiation. Their surface, made of iron atoms crushed to the brink of physical possibility. Beyond their astonishing physical properties, neutron stars play a pivotal role in the cosmic narrative. These stellar remnants are not just endpoints of star life cycles, they are key players in some of the universe's most dynamic events. These dense dwarfs often exist in binary systems, gravitationally bound to a companion star. In these systems, they can act like cosmic vampires, siphoning material from their partners. This process can lead to spectacular X-ray emissions, visible across vast interstellar distances, offering us a window into the high-energy processes of the universe. Perhaps most intriguing is what happens when two neutron stars are locked in a gravitational dance. As they spiral towards each other, they warp the space around them, creating ripples known as gravitational waves, a phenomenon predicted by Einstein, but only directly observed a century later. These gravitational waves carry information about their origins and about the nature of gravity itself, providing a new tool for astronomers to study the universe. The climax of this dance is a collision, a momentous event that unleashes a kilonova, an explosion so bright it briefly outshines the entire galaxy. These kilonovas forge elements heavier than iron, including gold and platinum, scattering them into space. Thus, neutron stars are not just theoretical curiosities. They are celestial forges where elements essential to life and to our very existence are created. In this way, these stars are intimately connected to us. The gold in your jewelry, the platinum in your car's catalytic converter. They were likely born in the heart of a kilonova. These quantum spheres provide a unique testing ground for theoretical physics. At their core, these stars are thought to contain matter at densities greater than that of an atomic nucleus. This ultra-dense environment is a playground for physicists, allowing them to test theories of nuclear physics and quantum mechanics in ways that would be impossible here on Earth. For instance, neutron stars may contain neutrons in a superfluid state, a condition where matter exhibits zero viscosity and can flow without friction. Understanding this state of matter could unlock secrets about the behavior of quantum particles under extreme gravitational and magnetic forces. Moreover, the intense gravity of neutron stars offers a real-world laboratory for Einstein's theory of general relativity. The gravitational field near this star is so strong that it significantly bends the path of light around it. This effect, known as gravitational lensing, which we already talked about, provides astrophysicists with a tool to observe and measure the distortions of spacetime, verifying predictions of general relativity in ways that are not possible in weaker gravitational fields like Earth's. Now, let us fly away from the radiant brilliance of neutron stars, those dazzling remnants of celestial giants, to a realm so vast and empty it defies imagination. A place so eerily desolate, it might seem like a cosmic myth. We are stepping into the heart of cosmic voids, the universe's grand and ominous enigmas, where darkness and mystery reign supreme. Picture an expanse so vast that entire galaxies within it are like distant islands scattered in an ocean of emptiness. This is the realm of cosmic voids, one of the largest structures in the universe. In these staggering stretches of near-nothingness, space itself seems to echo with the silence of absence. They are not just empty space, they are the universe's own deserts, vast and mysterious. While they might seem like vast areas of nothingness, there's actually more to them than meets the eye. Inside these voids, there are some galaxies, though they're few and far between. These galaxies are kind of special because they're often smaller and less developed than the ones we see in busier parts of space. It's like finding a small, quiet town in the middle of a vast desert, far away from the hustle and bustle of big cities. But galaxies aren't the only things in these voids. There's also dark matter, a mysterious kind of matter that we can't see, but know is there because of its gravity. Even though it's invisible, dark matter is really important because it helps shape the structure of the universe, including these big empty voids. These immense interstellar vacuums might also have something called baryonic matter. This is the same stuff that stars, planets, and everything on Earth is made of. In the voids, this matter is spread out like thin, almost invisible threads that stretch across the empty space, connecting the few galaxies that are there. The story of vast cosmic voids begins in the early cosmos. Picture the universe shortly after the Big Bang, a dense, hot soup of particles rapidly expanding. It was during this phase that tiny quantum fluctuations, small differences in density, emerged. As the universe expanded and cooled, these minuscule variations started to play a crucial role. Areas with slightly more matter began to attract more, forming the stars and galaxies we see today, much like snowballs rolling downhill and growing in size. Meanwhile, the regions with less matter, losing in this cosmic tug-of-war, became what we now recognize as cosmic voids. These are not mere empty spaces, but the footprints of the universe's infancy, sculpted by the earliest quantum fluctuations. As we gaze into these voids, we are looking back in time, witnessing the remnants of the universe's explosive birth and its dramatic expansion. The Boots Void is one of the most profound mysteries among these voids. Discovered in 1981 by astronomer Robert Kirshner and his team, the Great Boots Void caught the attention of scientists due to its unusually large empty space. Located in the constellation of Boots, this void is a gigantic expanse of near-nothingness. Imagine an empty sphere in space so vast that it spans approximately 330 million light-years in diameter. To put this in perspective, our Milky Way galaxy is just about 100,000 light-years across. This void contains very few galaxies, around 60, when, based on its volume, thousands would be expected. This scarcity challenges our understanding of the large-scale structure of the universe. To truly grasp the vastness of these cosmic voids, just imagine finding yourself in the middle of an enormous, silent desert under a moonless sky. This desert is so vast that its edges blur into the horizon, with no signs of life or landmarks in sight. The stillness is profound, almost tangible, much like the experience within the cosmic voids of the universe. In this desert, imagine occasionally spotting a faint, distant light, a lantern, perhaps, carried by an unseen traveler. These rare specks of light are akin to the few galaxies that exist within the cosmic voids. They are so isolated and distant from each other that their presence accentuates the vastness and emptiness around them. This immense isolation in the cosmic voids isn't just about the absence of visible objects. It's a reminder of the universe's enormity and the mysteries it contains.
Far, very far away from our Earth, in the vast and mysterious expanse of the universe, something truly terrifying unfolds. A cosmic event so powerful, it defies our wildest imaginations. Today, we're embarking on an extraordinary journey to witness this phenomenon firsthand. Brace yourselves as we engage our warp drive. Here we are, approaching a star at the end of its life, a ticking time bomb in the cosmic clock. This is not just any star, but a massive one, dozens of times larger than our Sun, now in its final tumultuous moments. This gargantuan star is about to undergo a catastrophic collapse. The intense gravitational pull at its core has finally overwhelmed the nuclear forces holding it together. This collapse triggers a supernova, an explosion so powerful it can briefly outshine an entire galaxy. But hidden within this brilliant outburst is an even more extraordinary event. The core of the star collapses into a black hole, a point in space where gravity is so intense that it ensnares all that approaches, even light, preventing its escape. As the black hole forms, it releases jets of gamma rays, shooting out into space at nearly the speed of light. These gamma ray bursts are the brightest electromagnetic events known to occur in the universe. They release more energy in a few seconds than our Sun will produce over its entire 10 billion year lifespan. But what exactly are gamma rays? They are a form of electromagnetic radiation, like the light we see and the radio waves we use for communication, but far more energetic. These rays have the smallest wavelengths and the most energy of any other wave in the electromagnetic spectrum. Gamma ray bursts, though exceptionally rare, are predominantly observed in galaxies billions of light years distant. These intense cosmic energy emissions pose significant risks if they occur near a hypothetical planet, especially within the same galaxy. A direct hit could strip protective atmospheric layers, leading to ecological catastrophes and potential mass extinctions. Gamma ray bursts are primarily classified into two types: long-duration bursts and short-duration bursts. Long-duration bursts, lasting more than 2 seconds, are believed to be caused by the collapse of massive stars. On the other hand, short-duration bursts, which last less than 2 seconds, are thought to result from the merger of neutron stars, or black holes in binary systems. These cosmic phenomena are not just harbingers of destruction. They also offer us invaluable insights into the workings of the universe. These high-intensity cosmic flashes help astronomers study the early universe, as they are bright enough to be seen from vast distances, acting as beacons that illuminate the distant and ancient cosmos. As we journey back to the safety of our own solar system, we carry with us a deeper understanding of gamma ray bursts, reminders of the immense power and unending mysteries of the cosmos. It's a humbling reminder that we are but a small part of a vast and dynamic universe, continually shaped by forces beyond our imagination. Now, let's briefly halt our voyage through the stars and shift our attention towards the blue and verdant sphere of Earth. Imagine for a moment a gamma ray burst occurring closer to our home, our planet, a vibrant oasis in the vastness of space, teeming with life. But what would happen if these intense cosmic energy emissions were to strike our world? If they occurred within our own galaxy and was aimed directly at Earth, the results could be devastating. These bursts emit intense high-energy radiation that can travel vast interstellar distances. Upon striking our planet, the gamma rays would first interact with the upper atmosphere, generating bright auroras, far more intense than any northern lights we've ever seen. But this beauty would be a harbinger of destruction. The intense radiation could penetrate our atmosphere, potentially stripping away the ozone layer that protects us from the sun's harmful ultraviolet rays. Without this protective shield, life on Earth would be exposed to deadly levels of UV radiation. This could lead to widespread ecological disasters, including mass extinctions of species sensitive to these changes. The gamma rays and subsequent cosmic rays could also create chemical reactions in the atmosphere, leading to a decrease in global temperatures, a phenomenon known as a nuclear winter. Electrical grids and satellites could be severely affected, disrupting global communication and navigation systems, plunging our technologically dependent world into chaos. But let's remember, such an event happening close enough to affect Earth is extremely unlikely. The vast distances in space act as a natural shield protecting us from these distant cosmic events. Now wait a minute. We have observed something unusual, something beyond our forecasts. An entity within our own solar system is exhibiting behaviors that defy our expectations. Our sun, the radiant lifeblood of our solar system, is not merely a celestial orb that graces our skies. It's a source of awe, warmth, and hope. As we cast our eyes upon its luminous glow, we can't help but feel a sense of connection to the cosmos. This fiery behemoth, a colossal celestial entity, orchestrates the cosmic dance of life and energy. It bathes our world in the glow of morning light, bringing each new day with the promise of possibilities. This is not just the familiar, life-giving star we know, but a tumultuous, fiery giant, awakening with unpredictable and powerful energy. Amidst its usual glow, we are witnessing the phenomenon of solar flares, colossal eruptions on the sun's surface, revealing its dynamic and often turbulent nature. First, we need to understand what solar flares are. A solar flare is essentially a sudden, rapid, and intense variation in brightness seen on the sun's surface. This phenomenon occurs near sunspots, often accompanied by a burst of energy that includes not just light, but a broad spectrum of electromagnetic radiation. But what triggers these dramatic solar outbursts? The sun, our star, is a maelstrom of nuclear activity, a massive sphere of burning gases primarily comprising hydrogen and helium. This nuclear fusion generates a powerful magnetic field, intricate and ever-changing. Over time, this magnetic field becomes twisted and tangled. Solar flares happen when these twisted magnetic fields suddenly and violently rearrange themselves, releasing vast amounts of energy. The energy released in a solar flare is immense. We're talking about an output equivalent to the detonation of millions of atomic bombs simultaneously. This energy is emitted across the electromagnetic spectrum, from radio waves to X-rays. It's a cosmic spectacle of light and energy that underscores the sun's powerful influence. When solar flares occur, they don't just release energy in the form of light and heat. They also emit streams of electrons and protons hurtling into space at nearly the speed of light. These high-energy particles are a key aspect of what we call space weather, and they play a significant role in the dynamics of the solar system's heliosphere. Interestingly, solar flares vary in frequency and intensity, typically following an 11-year cycle known as the solar cycle. During the peak of this cycle, known as solar maximum, flares become more frequent and intense. This cycle of activity is a fascinating aspect of the sun's behavior. offering valuable insights into its long-term patterns and influences. These solar flares can be really dangerous to us on Earth, but did you know an event already happened in the past that demonstrated this danger in a most dramatic way? On the morning of September 1st, 1859, Richard Carrington, a young but already accomplished English astronomer, was engaged in his routine observation of the sun. Carrington had built a private observatory at Redhill, Surrey, where he dedicated himself to solar studies, particularly sunspots, which were little understood at the time. Carrington's method involved projecting an image of the sun onto a screen using a telescope. This technique allowed safe observation of the solar surface without directly looking into the bright light of the sun, which could cause serious eye damage. On that fateful day, as he was sketching the sunspots, Carrington witnessed an intense bright light erupting from the sun's surface. The occurrence was sudden and startling. Two patches of intensely bright light appeared over the sunspots, growing in size over the next few minutes. Carrington described them as white light flares, a phenomenon not documented before. These flares were so bright that they were visible against the sun's glaring backdrop, a testament to their incredible intensity. Within hours of Carrington's observation, the effects of this massive solar flare started becoming apparent on Earth, though the connection wasn't immediately understood. The world was about to witness the largest geomagnetic storm in recorded history. The most vivid and immediate effect of the Carrington event was the appearance of spectacular auroras, natural light displays typically seen near the poles. During this event, auroras were reported as far south as the Caribbean, painting the night sky in breathtaking hues of red, green, and purple. These weren't just beautiful celestial shows. They were visual evidence of the sun's far-reaching influence on Earth's magnetosphere. But the impact went beyond the visual spectacle. The geomagnetic storm induced by the solar flares and subsequent coronal mass ejections caused widespread disruptions in the telegraph systems across Europe and North America. Telegraph operators reported sparks leaping from their equipment, some severe enough to start fires. In some cases, telegraph systems continued to send and receive messages even after being disconnected from their power supplies, operated solely by the electric current induced by the geomagnetic storm. The Carrington event was a wake-up call to the vulnerabilities of our technology to space weather. Remember, this was 1859, a time when electrical technology was in its infancy. The telegraph was the most advanced form of communication, and even this was not immune to the sun's influence. Let's now pivot to the present day and examine the potential impact solar flares could have on our modern world. In an era where technology permeates every aspect of our lives, the repercussions of intense solar activity are more significant than ever. Today, our society is intricately wired and heavily reliant on technology. From communication networks to power grids, from satellite operations to air travel, technology is the backbone of our day-to-day functioning. But this dependence also makes us vulnerable to the whims of solar activity, much like the telegraph systems were back in 1859. Imagine a scenario where a solar flare of Carrington Event magnitude occurs now. The first to feel the impact would be our satellites. These sophisticated pieces of technology orbiting Earth are critical for GPS, telecommunications, and weather forecasting. A powerful solar flare can disrupt their operation, leading to a cascade of failures. GPS systems could go offline, affecting everything from your smartphone's mapping services to the precision timing required for financial transactions. Next in line would be the power grids. A solar storm could induce currents in the long power lines, potentially overloading transformers and causing widespread blackouts. The repercussions of a prolonged power outage are immense, from the cessation of daily activities to the crippling of emergency services and economic losses running into billions. The danger extends even into the skies. Solar flares can disrupt the Earth's ionosphere, affecting radio communications. This would have a direct impact on aviation, particularly for flights over polar regions where the impact of solar activity is the most pronounced. Pilots could find themselves without vital communication links, and the safety of passengers could be at risk. But the potential destruction isn't limited to just technological systems. The increased radiation from a solar flare could pose a serious threat to astronauts in space, particularly those aboard the International Space Station. Without the protection of Earth's atmosphere, they are vulnerable to the high-energy particles released during a solar flare. This scenario isn't mere speculation. In recent years, there have been several near misses. In 2012, a massive solar storm similar in scale to the Carrington Event missed Earth by just 9 days. Had it hit, the impact on our modern, interconnected world could have been catastrophic. The possibility of a solar event disrupting our technology-dependent society isn't a question of if, but when. This underscores the need for robust and resilient systems that can withstand such celestial challenges. Investment in better forecasting, shielding technologies, and contingency planning is crucial to mitigate the potential destruction posed by solar flares.
In the haunting shadows of existence, where the echoes of despair resonate, we find ourselves pondering the enigma of reality. In this realm of endless questions, we seek to unravel the tapestry of what we perceive as truth. Are we mere spectators in a universe of illusions, or architects of the reality we experience? A journey that challenges the very essence of our understanding of existence. We start by diving into the profound question that has captivated philosophers and scientists alike. Is the reality we perceive actually independent of our consciousness? This inquiry takes us from the ancient philosophical schools, where thinkers like Plato contemplated a world beyond sensory perception, to the modern corridors of quantum physics, suggesting that our observation might indeed shape the reality we witness. As we traverse this enigmatic landscape, we confront the elusive nature of objective reality. Is there a single, unalterable truth, or is reality a mosaic crafted by our collective perceptions and experiences? At the core of our exploration is the human brain, a marvel of evolution and a master architect of our perceived world. Neuroscience has unveiled that our brains are far more than mere receivers of external stimuli. They are creators of the world we experience. Every sensory input, every neural signal, contributes to the intricate tapestry of our perceived reality. This realization leads us to ponder. If our brains are constructing what we perceive as reality, what lies beyond this constructed realm? Are there dimensions of existence that our current cognitive abilities cannot fathom? Our odyssey doesn't stop there. We delve into the historical evolution of these ideas, examining how great minds from Descartes, who asserted the primacy of consciousness in cogito ergo sum, to contemporary theorists discussing the possibilities of a simulated reality, have shaped our understanding of existence. We explore groundbreaking theories in physics, like string theory, that paint a picture of a universe far more interconnected and less materially bound than we ever imagined. And we consider how these concepts are reshaped in the age of artificial intelligence and virtual realities, challenging our conventional notions of what it means to be real. Throughout history, philosophers have debated the nature of reality. Plato, a famous Greek philosopher, introduced the allegory of the cave, suggesting that our perception of reality is like seeing shadows on a cave wall, far from the true form of things. Fast forward to René Descartes, who famously said, "I think, therefore I am," implying that the only certainty is our consciousness. In more recent times, the debate continues. Philosophers like Immanuel Kant argue that while a reality exists independently of us, our understanding of it is filtered through our senses and mind, shaping a subjective experience. This means that our personal, subjective realities might be vastly different from an objective, absolute reality, if such a thing even exists. Think about how this plays out in everyday life. Each of us experiences the world through our own lens, influenced by our personal experiences, culture, and beliefs. Your joy might be another's sorrow. Your up might be another's down. This shows that reality as we experience it is deeply personal and subjective. But does this challenge the idea of an objective, unchanging reality? Some modern thinkers say yes. They argue that what we call reality is actually a construct of our perceptions, influenced and molded by the unique wiring of our brains and the culture we live in. Our perception plays a crucial role in shaping our reality. For instance, color. What I see as red might not be the same as what you see as red. We can agree on the wavelength, but the experience, that's subjective. And it's not just about sight. It's about all our senses and even our emotional and cognitive interpretations. Consider how technology and media shape our view of reality. The news we consume, the social media algorithms, they all filter and alter our perception of the world, sometimes creating echo chambers that reinforce our subjective reality. So, what does this mean for us? Understanding the subjective nature of reality encourages us to be more open-minded and empathetic. It challenges us to consider perspectives outside our own and recognize that what we perceive as real is just one version of a much larger, more complex story. Quantum physics, a field that may seem daunting, holds the key to unlocking some of the universe's deepest mysteries. At its core, quantum physics studies the behavior of the smallest particles in the universe, things like electrons and photons. It's a world where the rules of classical physics, like those set out by Isaac Newton, don't always apply. Here, particles can exist in multiple states at once, a concept known as superposition. One of the most mind-bending ideas in quantum physics is Heisenberg's uncertainty principle. It tells us that the more precisely we know the position of a particle, the less we know about its momentum and vice versa. This uncertainty challenges the idea of a fixed, predictable reality, suggesting that at a fundamental level, nature is inherently unpredictable. Another intriguing concept is quantum entanglement. When particles become entangled, the state of one instantly influences the other, no matter the distance separating them. This phenomenon, which Einstein called spooky action at a distance, hints at a level of interconnectedness in the universe that defies our conventional understanding of space and time. Then there's the observer effect, famously illustrated by the Schrödinger's cat thought experiment. It suggests that the act of observation can affect the outcome of an event at the quantum level. Does this mean that reality, at its most fundamental level, is shaped by our observation? It's a question that continues to puzzle scientists and philosophers alike. You might wonder, how does all this abstract quantum weirdness relate to our everyday reality? While these effects are most noticeable at the microscopic level, they lay the foundation for the larger world we experience. They challenge us to rethink our notions of reality, causality, and even consciousness. Quantum theory thus presents a reality that's dynamic and probabilistic, contrasting starkly with the predictable, deterministic world of classical physics. This has led some to propose that reality might be more of a tapestry woven from probabilities than a single unchanging narrative. The philosophical implications of quantum physics are immense. If reality at the quantum level is so fluid and interconnected, could the same be true for the reality we experience daily? Are the solid objects and fixed events we perceive just a convenient illusion, masking a much more dynamic and interconnected universe? This brings us to the limitations of our perception. Just as a radio can only tune into certain frequencies, our senses might be equipped to perceive only a fraction of the universe's true nature. What lies beyond our sensory perception could be realms of reality that are as strange and wondrous as the quantum world. Quantum physics not only revolutionizes our understanding of the microscopic world, but also invites us to question the very fabric of our perceived reality. We might find that the nature of reality is far more intricate and interconnected than we ever imagined. Consciousness is one of the great mysteries of science and philosophy. It's the essence of our being, the I am experience. It's not just about being awake, it's about being aware, being able to experience and reflect on the world around us. But how does this consciousness arise, and how does it shape our reality? Our brain is a masterful interpreter. Every moment, it processes a flood of sensory data, filters it, and creates a coherent picture of the world. Neuroscientists like Anil Seth argue in works like Being You that what we perceive is a controlled hallucination, a reality constructed by the brain from incomplete sensory inputs. Perception is not just about gathering data, it's about interpretation. This means our reality is subjective. For instance, how we perceive color or sound can vary dramatically from person to person. It's not just about the external world, but about how our brains and minds interpret that world. Our emotions and memories play a crucial role in perception. They color our experiences and can alter how we perceive reality. A happy memory can make a familiar place glow with warmth, while a sad one can cast a shadow over it. Our current emotional state can even change how we perceive colors and sounds. Given this, it's not a stretch to say that each of us lives in a slightly different reality. The world as I perceive it, filled with my interpretations, emotions, and memories, is unique to me. The same is true for you. We're all experiencing our own version of reality, constructed by our brains. Consider the limitations of our senses. They provide us with a useful but limited representation of the world. For instance, we see only a tiny fraction of the electromagnetic spectrum. What we perceive as reality is really just a small slice of what's out there. What lies beyond our sensory perception? Technologies like telescopes and microscopes have expanded our view, but there's still so much that remains unseen, unfelt, unheard. This begs the question, what aspects of reality are we missing simply because we lack the senses to perceive them? While our individual realities are unique, we also share a common reality. Through communication and shared experiences, we build a collective understanding of the world. This shared reality is vital for our survival as a species and forms the basis of our societies and cultures. Exploring human consciousness and perception reveals a fascinating truth. Our experience of reality is a complex interplay between the world around us and our internal interpretation of it. Imagine you're just a brain, floating in a vat, connected to a supercomputer that simulates your entire reality. This thought experiment, known as Brain in a Vat, challenges the idea of a physical reality. How do you know if your experiences are real or just electrical impulses fed to your brain? It's a modern twist on Descartes' skepticism, questioning the certainty of our experiences. Next, let's turn to Schrödinger's cat, a famous thought experiment from quantum mechanics. A cat is placed in a box with a radioactive atom that might kill it. Until you open the box, the cat is both alive and dead, according to quantum theory. This paradox illustrates the strange reality of quantum superposition and challenges our everyday understanding of life and death. Consider the ship of Theseus, an ancient thought experiment. If you replace every part of a ship over time, is it still the same ship? This puzzle explores the nature of identity and change. It asks us to think about what makes something fundamentally itself. Is it its material composition or its form and function? Then there's the trolley problem, a moral thought experiment. A runaway trolley is heading towards 5 people tied to the tracks. You can pull a lever to switch the trolley to another track, but it will kill one person there. Do you pull the lever? This experiment probes our moral decision-making and the philosophical debate between utilitarianism and deontological ethics. Let's revisit Plato's allegory of the cave. Prisoners in a cave believe shadows cast on a wall are reality. When one prisoner is freed and sees the outside world, he realizes the shadows are mere illusions. This allegory asks us to consider how our perception might be limited or manipulated, and what reality truly is. Finally, let's explore the multiverse theory, a concept that extends beyond the familiar universe. It proposes the existence of multiple, perhaps infinite, universes, each with different laws of physics. This mind-bending concept expands our understanding of reality, suggesting that our universe might just be one of many. From questioning the nature of objective reality to delving into the mysteries of quantum physics, from understanding the intricate role of our consciousness and perception in shaping our world to engaging with mind-bending thought experiments, we've ventured far beyond the ordinary, embracing the unknown and valuing the richness of diverse perspectives. This exploration has been more than an intellectual pursuit. It's a reminder that our perception of reality is a dynamic interplay of the world around us and our internal consciousness. As we part, take these ideas with you, let them inspire and challenge you, and remember, perhaps our truest understanding of reality lies beyond this life. Maybe, in the moment of our final passage, we encounter the ultimate revelation of existence, seeing reality in its fullest form.
Explosions. They're synonymous with destruction, chaos, and disorder. But what if I told you that the most colossal explosion known to us, the Big Bang, did the exact opposite? Instead of wreaking havoc, this massive explosion set forth an extraordinary series of events, creating not chaos, but a universe teeming with order and beauty. From this cosmic turmoil emerged our home, Earth, a cradle for life, an oasis in the vast cosmic desert. And within this haven, a breathtaking display of life. From majestic oceans with rhythmic waves to dense, vibrant forests, teeming with diverse fauna and flora. Every wave that caresses the shore, every leaf that dances in the wind, every star that twinkles in the night sky. A symphony of perfect order, seemingly choreographed with meticulous precision. Amidst this splendor stands humanity, a testament to the incredible order and intricate perfection birthed from the universe's most monumental explosion. How did an event so cataclysmic pave the way for the meticulous balance and perfection we witness in the cosmos, from the depths of our oceans to the expanse of the skies? In the face of such overwhelming harmony and precision, one can't help but wonder, could this all be the work of mere chance? Or does it point to the existence of a divine architect, a higher intelligence, a god? For centuries, humanity gazed at the stars, crafting narratives about the cosmos. In the 17th and 18th centuries, a prevailing belief was that the universe was a static, unchanging expanse, a fixed backdrop to our earthly lives. This steady-state theory, embraced by many luminaries of the era, painted a picture of an eternal universe. To them, the cosmos had always been as it is, unchanged since the dawn of time, an idea that resonated with the concept of a timeless, unchanging creator. In the 1920s, Edwin Hubble made several stunning discoveries about distant galaxies, and one of those discoveries was that the universe was expanding. With astonishing rapidity, galaxies were eroding from one another. This was a universe not static, but ever-changing and progressing. The key to this cosmic revelation is redshift. Light from distant galaxies shifts towards the red end of the spectrum as they move away, hinting at a universe continuously being shaped and stretched. This redshift, a kind of cosmic Doppler effect, is a whisper from the universe, telling us that it is not a stagnant creation but one that is alive, expanding, and evolving. This shift from the steady state to an expanding universe transformed our understanding of the cosmos. Edwin Hubble's groundbreaking work was just the beginning. His discovery that galaxies are moving apart led to a profound realization: if the universe is expanding, then it must have had a beginning. This beginning, often envisioned as the Big Bang, can be seen as a moment of creation, an inception point where time, space, and matter were all born from nothingness. Does this not point towards a creator, an initial mover? Consider the precision required for such an event. The Big Bang was not a chaotic explosion, but a finely tuned burst of creation, setting the stage for everything that followed. This precision suggests a deliberate design. The cosmic microwave background radiation, a faint afterglow of the Big Bang, further tells us of a universe that began in a state of high order. This order, emerging from a point of singularity, raises questions about the nature of the divine. As galaxies formed from these cosmic seeds, we see a pattern of order and structure emerging from what was once a singular point. Is this not akin to the concept of a universe crafted by an intelligent designer? Observing supernovae in distant galaxies further illustrates the vastness and complexity of this universe, reinforcing the idea of a meticulously crafted cosmic environment. Each celestial body, each galactic event, speaks of a universe that is not random but purposeful. As I mentioned at the beginning of this video, we typically associate explosions with destruction, chaos, and disorder, often leaving nothing but devastation in their wake. However, the Big Bang stands as a remarkable exception to this rule. Contrary to causing disorder, it gave birth to order. Instead of wreaking destruction, it forged complexity in the cosmos. Far from creating chaos, it meticulously orchestrated the perfection we observe in the universe. This phenomenon intricately designed everything from human DNA and animals to the very essence of nature that surrounds us. The Big Bang, thus, is not just a story of an explosion, but a narrative of creation and intricate design. And it is this incredible orchestration of the universe, this profound genesis of life and complexity, that leads many people on Earth to attribute such marvels to a higher power, a being they call God. Having witnessed the grandeur of the cosmos and the delicate intricacies of Earth, our exploration now leads us to one of the universe's most profound mysteries: the nature of time. Time, an omnipresent force that is intimately familiar, yet profoundly elusive. It's a concept that has captivated human thought, a continuous thread that weaves through the very fabric of existence. Time dictates the rhythm of the cosmos, from the orbit of planets to the flutter of a butterfly's wings. It's a dimension that governs change and progress, yet its fundamental nature remains shrouded in enigma. The genesis of time, as indicated by the cosmic dawn theory, signifies not only the emergence of the universe, but also the origin of time itself. This fusion of time and space at a unique point poses a profound challenge to our comprehension of the eternal. Albert Einstein's revelations unveiled time as a malleable fabric, intertwined with space. Time dilates, stretches, and contracts, defying the notion of a fixed, unchanging dimension. Such dynamism in the very essence of time stirs profound questions about its origin. In various spiritual and philosophical traditions, time is often portrayed as a divine construct, an orchestrated element within a larger cosmic design. This view elevates time from a physical phenomenon to a deliberate creation of a higher power. The paradox of time, having a beginning yet flowing endlessly, nudges us toward the contemplation of something or someone beyond time, an eternal entity perhaps, for whom time is a canvas of creation. This intricate tapestry of time, woven into the universe, leads us to speculate about its crafter. The complexity and precision within the temporal dimension seem to transcend mere chance or random emergence. Contemplating the vastness of the universe and the intricacies of time, one might wonder if this is all the work of a cosmic architect. This amazing complexity of time, challenging to fully comprehend, could very well be evidence of a creator. Now bear with me, because we are about to delve into something truly astonishing: the insane fine-tunings of our universe. This exploration will not only blow your mind, but may also provide compelling evidence for the existence of a god. The universe is a tapestry of intricate complexity and beauty, displaying a level of fine-tuning that transcends mere chance. Every element, from atomic forces to the grand ballet of galaxies, appears meticulously calibrated, hinting at a universe crafted with purposeful intent rather than random occurrence. At the core of this fine-tuning are the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. Each is so precisely balanced that any minor alteration would make our universe unrecognizable or even non-existent. The precision extends to physical constants, such as the speed of light and the electron's charge. These constants are fine-tuned to a degree that allows the cosmos to harbor stars, planets, and life. Even the slightest deviation could lead to a barren universe. Molecular bonding, governed by specific laws, is vital for life. The exactness of these rules is such that any slight variations would hinder the formation of essential biomolecules, fundamental to biological existence. Stars, the universe's cosmic forges, epitomize this fine-tuning. The nuclear reactions within stars balance delicately, enabling the synthesis of elements necessary for life. The lifespan of stars, including our Sun, is also finely tuned. Their longevity and stability are essential for the emergence and sustenance of complex life forms. The universe demonstrates a precise balance in the number of electrons and protons. Any significant imbalance would lead to a universe overrun by electromagnetic forces, hostile to the development of complex structures. Oxygen's role in rendering water a universal solvent is pivotal for life. The unique balance within water's molecular structure is essential for various biological processes, illustrating a universe seemingly tailored for biological complexity. Earth itself reflects this fine-tuning. Its distance from the Sun, atmospheric composition, and the presence of water collectively forge ideal life-sustaining conditions. Earth's mass strikes a delicate balance, retaining vital gases for life while shielding us from harmful cosmic radiation. The universe's overall density is finely tuned, set at a critical value that prevents collapse or unchecked expansion, fostering a stable environment conducive to life. The cosmic microwave background radiation, a relic of the universe's birth, is uniformly distributed, with just enough variance to enable galaxy formation and other cosmic structures necessary for a life-bearing universe. Earth's magnetic field, calibrated to protect against harmful solar radiation, is crucial for the evolution of complex life forms. Similarly, Earth's nearly circular orbit ensures stable, life-supportive temperatures, avoiding the extremes that a more eccentric orbit would cause. Our strategic position in the Milky Way's galactic habitable zone shields us from galactic hazards while providing access to essential life-building elements, acting as a cosmic sanctuary. The rate of supernovas is balanced, essential for disseminating life's building blocks while preventing destructive radiation exposure, allowing life to thrive. Stellar formation and stability showcase cosmic engineering at its finest. The equilibrium between a star's gravitational pull and nuclear reactions fosters environments where planets can prosper over billions of years. A prerequisite for life, Earth's axial tilt contributes to our planet's stable climate, vital for life. An axial tilt significantly different could result in devastating climatic extremes. Jupiter acts as a cosmic shield, its gravitational field deflecting or absorbing potential asteroid and comet threats, thus protecting the inner planets from frequent catastrophic impacts. The Earth's atmosphere is transparent to essential light for life, yet opaque to much harmful radiation, a perfect example of fine-tuning critical for life-supporting processes like photosynthesis. Our oceans, rich in life, play a crucial role in Earth's carbon cycle and climate regulation. The balance within marine ecosystems is vital for sustaining life and maintaining planetary habitability. The Moon's relative size to Earth influences tidal forces, essential for the movement of ocean waters, which may have been crucial in the early mixing of life-forming chemicals. The magnetic fields of stars, including our Sun, are precisely strong enough to shield planets from intense cosmic radiation, preserving planetary atmospheres and supporting surface life. In the vast expanses of space, beyond what our eyes can see, lurk dark matter and dark energy, unseen forces that challenge our understanding of the universe. These eerie, shadowy elements, making up most of our cosmos, could hold clues to its ultimate architect. Dark matter, though invisible, reveals its presence through its gravitational pull. It acts as the cosmic glue, holding galaxies together in a delicate balance. This unseen force, orchestrating the structure of the cosmos, might reveal a universe composed with exacting detail. On the other hand, dark energy remains an enigma, driving the accelerating expansion of the universe. This mysterious energy, defying gravity, suggests a universe that is not just expanding, but doing so at an ever-increasing pace. The precise balance between dark matter and dark energy is a cosmic conundrum. Their interplay, a fine-tuned dance that allows galaxies to form and life to exist, raises profound questions about the nature of the universe's inception. As we gaze into the night sky, we are not just observing stars and galaxies, but also feeling the presence of dark matter and dark energy. These unseen forces shaping our universe might hint at the existence of a higher power, an omnipotent force that transcends our physical reality. The complexity and diversity of life, exemplified by the intricately designed DNA molecule, operate within narrowly definite conditions, further suggesting a universe fine-tuned for life. This leads us to the anthropic principle, positing that the universe appears fine-tuned for conscious life because otherwise, we wouldn't be here to observe it. This principle suggests a cosmos tailor-made for our existence, possibly hinting at a higher purpose or intelligence. As we ponder the universe, from the smallest particle to the vast galactic clusters, the observed precision and harmony are staggering. This perfect orchestration might be interpreted as evidence of a divine hand at work, shaping the universe with purpose and foresight.
The awe-inspiring flawlessness of this universe is truly remarkable. We all know that one inevitable truth we must confront in our lives is our own mortality. It's a sobering thought, isn't it? We are all bound to face death someday, and this reality often leads us to explore deeper questions about existence, including the possibility of a divine force. Particularly when we observe the darkness in our world, the presence of evil, and the injustices that sometimes appear to go unpunished. We see the evil in the world, the acts of cruelty, the murderers who take the lives of the innocent, and the seemingly unaccountable wrongdoings that shatter lives. It's easy to question why a world with so much beauty and potential also harbors such darkness. In the face of these grim realities, the idea of a divine presence becomes a source of hope and solace. Many of us seek to believe in a higher power, in a God who provides justice when human systems fail. The thought that there might be a reckoning after this life, where the wrongdoers are held accountable for their actions, brings a sense of balance and moral order to an otherwise chaotic world. Consider the innocent lives lost and the profound suffering experienced by many. If we accept the existence of a God who ensures justice, then perhaps there is solace in the idea that even those who escape earthly justice will one day face a higher court. In contemplating the existence of a God, we often find ourselves seeking answers to the questions raised by life's darkest moments. It's a topic that stirs deep emotions and underscores the yearning for justice, compassion, and a sense of purpose in a world that sometimes leaves us searching for meaning. Now, let's delve into another intriguing facet that could potentially be indicative of the existence of one divine creator: objective morality. Objective morality posits that certain moral values and duties are universally true, transcending individual beliefs or cultural relativism. It suggests that there's an inherent moral order, independent of human subjectivity, which prompts us to ponder its origins. If moral values are indeed objective, the question arises: what provides the foundation for these universal moral truths? This is where the concept of a divine creator enters the conversation. The argument unfolds as follows. The existence of objective moral values is best explained by the presence of a higher intelligence, a moral lawgiver who serves as the source of these moral principles. In this perspective, the divine creator becomes the ultimate standard of morality, and the very fabric of objective morality becomes a compelling piece in the broader puzzle of the existence of one divine creator. The concept of necessary existence, often explored in philosophical discourse, is integral to arguments seeking to establish the existence of God, notably through versions of the cosmological argument. This line of reasoning begins by acknowledging that our world comprises contingent beings, entities whose existence is not necessary and could have been otherwise. Confronted with the question of why contingent beings exist, proponents of the cosmological argument contend that an infinite regression of contingent causes is not logically satisfactory. To address this, the argument posits the existence of a necessary being, a being that exists independently and does not depend on anything else for its existence. This necessary being is then identified with God, conceived as a self-existent and uncaused entity, serving as the ultimate cause and explanation for the existence of all contingent beings. In this way, the concept of necessary existence becomes a linchpin in the philosophical reasoning that seeks to elucidate the existence of a divine creator, providing a foundation for understanding why anything exists at all. Imagine a chain of dominoes standing upright, each representing a contingent being in the universe, things that exist but could have not existed. Now, consider that each domino falls because the one before it pushed it. If this causal chain extends infinitely backward, we are left with an unsatisfying mystery. What initiated the sequence in the first place? To avoid an infinite regress, imagine a dominoes pushing hand, the necessary being. This hand doesn't need another hand to set it in motion. It simply is, providing the impetus for the entire chain. In the realm of philosophical discussions about God's existence, this necessary being is likened to God, a self-existent, uncaused entity that serves as the ultimate explanation for why the chain of contingent beings exists at all. Just as the hand is necessary to set the dominoes in motion, the concept of necessary existence offers a philosophical framework suggesting that a divine creator is necessary to set in motion the existence of contingent beings in our universe. Take a moment to reflect on the undeniable truth that you watching these pixels dance on your screen, are a living testament to the existence of something beyond the mundane. In a profound exploration of the divine, Ali Benazir's research unravels the extraordinary rarity of individual existence, spotlighting you as a testament to the unparalleled craftsmanship of a divine creator. As we delve into the intricate landscape of the human body, the mind is drawn to the breathtaking complexity and perfection that permeate every aspect. Consider the intricacy of human cells, microscopic entities that function with unparalleled precision, orchestrating a myriad of processes essential for life. The human brain, a marvel of complexity, houses billions of neurons that form an intricate network capable of consciousness, thought, and self-awareness. The heart, tirelessly pumping blood through a vast circulatory system, symbolizes not only biological perfection, but also the rhythm of life itself. Zooming in further, contemplate the uniqueness of your fingerprints, a distinctive code that sets you apart in a world of billions. The nervous system, a symphony of electrical signals and chemical interactions, facilitates the seamless coordination of muscles, enabling movement and expression. Your eyes, marvels of optical engineering, capture the beauty of the world with astounding clarity. Moreover, consider the profound ability to communicate in diverse languages, a trait that sets humans apart from the animal kingdom. Speaking various languages, unlike animals, highlights a cognitive complexity and linguistic diversity that speak to the unique essence of human existence. Saying you came out of nowhere is like saying something super unlikely happened. Imagine the universe as a giant painting, and you being here is like all the colors and shapes lining up just right. It's not random, it's like the universe had a plan. Picture the planets moving, gravity doing its thing, and all the different pieces coming together. Your existence is like a dance of these cosmic forces, making you a part of this big, beautiful painting. Let's zoom in on the often overlooked mosquito. Far more than a mere annoyance, this tiny insect unveils an astonishing complexity that hints at the handiwork of a masterful creator. Take its proboscis, for example, a marvel of engineering that effortlessly pierces skin, navigates blood vessels, and feeds without triggering immediate notice, showcasing a level of precision that leaves us in awe. Now consider the mosquito's life cycle, a meticulously orchestrated dance through egg, larva, pupa, and adult stages. The seamless metamorphosis from aquatic larvae to airborne adults is nothing short of a biological symphony, underscoring a deliberate design in its very existence. Let's not forget its sensory organs, a sophisticated array of antennae and sensors finely tuned to detect carbon dioxide, body heat, and specific chemicals. This creature is equipped with an astonishing repertoire of tools for survival. The mosquito, with its incredible functionality and purpose, stands as a testament to the vast complexity that extends far beyond our understanding. Furthermore, it is getting harder to reject the existence of a creator as we take in the beauty, intricacy, and purpose woven into every aspect of this enormous cosmos. If you're as amazed at the universe's great beauty as I am, there's a strong argument to be made for the possibility that the accuracy we see is the product of a cosmos designer. If these ideas speak to you, please click the like button, subscribe for future musings on the mysteries of the cosmos, and add your own opinions to the cosmic thread of comments below. Until our next cosmic adventure, never stop wondering or searching, and allow the wonder of the cosmos to inspire us all.